Hello and welcome. We are on page 75, starting to look at stoichiometry in the lab. The first thing we're looking at with stoichiometry in the lab is titration or volumetric analysis. In titration, it is a laboratory procedure where a substance of known concentration, which is called the titrant, is reacted with another substance in a solution of unknown concentration called the analyte. The goal of a titration is always to determine the unknown concentration. Most of the time we use this with our acid-base neutralization reactions, and we're looking for the unknown concentration of an acid or a base. We do this using the equivalence point. The equivalence point is the point in the titration where the added titrant has completely reacted with the analyte. So if we know how many moles of titrant that we've reacted, we can figure out how many moles of analyte have reacted using that balanced chemical equation. When we're talking about acid-base titrations, this is where the amount of acid is stoichiometrically equal to the amount of base, or where moles of H plus is equal to moles of OH minus. When we are doing a titration, we determine where this equivalence point is based on the end point. So the end point is where we have a color change based on an indicator. If we choose the correct indicator, we have that color change or pH change happening at where our equivalence point should be. So let's go and look at the math behind this titration. Here we see that it takes 24.68 milliliters of 0.1165 molar hydroxide to neutralize or to titrate the 0.2931 grams of an unknown acid. And it is a monoprotic acid. That monoprotic acid means that we have one H plus. Well, our base has one OH minus, so these are reacting in a 1-to-1 mole ratio. So if we can figure out how many moles of OH minus that we used, that's how many moles of H plus that we had. That's because we titrated to that equivalence point, which again is where moles of H plus is equal to moles of OH minus. So first we want to go and figure out how many moles of OH minus that we have. Well, we have our volume and we have our molarity. Molarity times volume will give us the moles of NaOH. So we end up having 0.002875 moles of sodium hydroxide. Well, in sodium hydroxide, there is one hydroxide, so our moles of sodium hydroxide is equal to the moles of just the hydroxide. Well, we titrated to the end point, which is essentially, or should be, if we did the lab correctly, the equivalence point. At the equivalence point, moles of OH minus is equal to moles of H plus. So we also have 0.002875 moles of H plus. Because we have a monoprotic acid, which again meant that our acid had one single proton in it, our moles of H plus is equal to our moles of acid. So in the end, we find that we had 0.002875 moles of acid present in our original sample of that monoprotic acid. Part B is asking us to find the molar mass of that unknown acid. Anytime we want to find molar mass from a sample information that was given, we need to know the mass of the sample and the number of moles in that sample to get that gram to mole ratio. So in this case, we need to know the grams of the acid in our sample and the moles of the acid in our sample, both of which we already have. The original narrative of the problem told us that we had 0.2931 grams of our monoprotic acid. In part A from our titration information, we found that we had 0.02875 moles of acid in that sample. Divide these two and that gives us our molar mass of 101.9. Units for molar mass are always gram per moles, and we're making sure we kept those 4 sig figs throughout this whole entire problem. So there's an example of titration. Again, big point there, moles of acid is equal to our moles of base.